Okay, let's have a look here. So let's draw our suitcase and we'll just label the sides X, Y, H to keep it the same letters in the question. So we know that the X plus the Y plus the H must be less than or equal to 62. So we could say H equals 62 minus X plus Y. The volume equals X, Y, H. The problem is, how can I replace the X, Y here? So um, you see, I know the X and the Y should be equal. So X can be swapped with Y, so without loss of generality, we need X to equal Y. So H would equal 62 minus 2X. So X would equal, so X would equal 62 minus H over 2. 62. So if we sub that in, we get V equals 62 minus H over 2 squared times H. So we could take the 2 out for sure. Divide by 2. So that's H over 31 minus a half H squared. So, that matches up there. That's the volume. But I don't know if that's the maximum volume, like, because I used this here. I think I know what we can say here. I think I know what they're getting at. So I think what would be better would be to say the volume would equal the area times the H. And if that is fixed, then what that means, a maximum volume would correspond to a maximum area on the base. So that means maximum area has to be a square, because we can say area equals X, Y. And then the X plus Y has to equal 62 minus H. So I don't think that's helpful right now. I think it's more helpful to say X plus Y equals 62 minus H. So that means the area will equal X. And we'll just call this a constant K. So that would be K minus Y. So the area would be Kx. Sorry, that's the wrong. I should say K minus X there. So minus X squared. So dA the x equals k minus 2x, which equals 0. So that means that x equals k over 2. And that would also mean, from this formula, that y equals k over 2, which means we have a square. Okay, good. Good, good. And let's just check that's a maximum. d2a dx squared equals minus 2, which is less than 0, which makes it a maximum. So the volume would have to be a square. This is for get the maximum. The square times the height. So that would be what we said earlier, x squared times h. So we have 2x plus h equals 62. So that would be, if I just put the h in front, h, and then x is 62 minus h over 2 squared. So that would be h 31 minus a half h squared. But now we have to find the height. So this is the formula of the volume that will make the biggest suitcase subject to the constraints. So I feel like we could differentiate this and make this equal to 0. Or is there anything easier to do? Let's try it. So dv dh is 31 minus a half h squared plus 2h times 31 minus a half h times minus a half, and that should equal 0. So it's going to be a quadratic. I don't know if this is the best way now. That's the maximum volume in terms of h. No, I don't think I have to. Maybe I don't have to go to that trouble. Because I know that the x has to be, oh, that has h in it though. 62. Okay, so if we say x plus y plus h has to equal 62, so x plus y plus h has to equal 62. Oh yeah, no, that's not going to work. Okay. I'm going to multiply this out though. B equals h times 1024 minus 31h plus a quarter h squared. So B is 1024h minus 31h squared plus a quarter h cubed, and then the derivative is 1024 minus 62h plus 3/4 h squared equals 0. So I think something's gone wrong here. Let me pause for a minute just to check my algebra. Yeah, I see my mistake. 31 squared is 961. So you have here h equals 62, which obviously doesn't make any sense here because that means the triangle, the suitcase has a base area of 0, or 62 over 3 inches. Now, I don't think that's the answer at the back, though. Oh, it is. Excellent. Okay. Let's just confirm that that is indeed the maximum by calculating the second derivative. That'll be minus 62 plus 3 over 2h. If we sub that in, yeah, it's minus 31. So therefore, a maximum then. What height leisure? Yeah. Interestingly, yeah. 62 over 3. Yeah, okay. Let's have a look at 316 now. So that was 315. Right. You are constructing a cardboard box with dimensions of 2 by 4. You then cut out equal from each corner. What are the dimensions of the box to the largest volume? Okay, so let's calculate the volume for 316. So the volume would be 4 minus 2x. That's this length here. Times 2 minus 2x times x. So that would be 4 minus 2x times 2x minus 2x squared. So that would be times 4, 8x minus 8x squared minus 4x squared plus 4x cubed. So that's 4x cubed minus 12x squared plus 8x. dv dx equals 12x squared minus 24x plus 8 equals 0. So two answers here. So 1.58 or 0.4. I feel like that's not quite right. Let's check it out again. Four minus 2x. 2 minus 2x. And height of x. 4 minus 2x. 2x minus 2x squared. Then times this by 4. 4 times 2, 8x minus 8x squared minus 4x squared plus 4x cubed. So that's 4x cubed minus 12x squared plus 8x. And the derivative is 12x squared minus 24x plus 8. Yeah, okay. That looks right. So x will equal 3 plus root 3 over 3, or 3 minus root 3 over 3. Now, do both answers make sense here? So we need to note that we can't cut off more than 2. Like x has to be less than 1. So, yeah, we'll have to reject this answer because that's cutting off too much. So, seems to be this answer here. Meters. What are the dimensions of the box with the largest volume? So, let's see now. So 4 minus 2 times 3 minus root 3 3. So that would be 6 plus 2 root 3 over 3 meters by 2 root 3 over 3 meters by x, which is 3 minus root 3 over 3 meters. Okay. I think that's right. I just don't like it when I get cert answers like this. But I think that's it. Okay. 317. Find the positive integers that minimize the sum of the numbers and its reciprocal. Find the positive integers that minimize the sum of the numbers and its reciprocal. So z equals, find the positive integers that minimizes the sum of the numbers, the sum of the number. Oh, find the positive integer that minimizes the sum of the number and its reciprocal. Oh, okay, so x plus 1 over x, we want to minimize the y. All right, so the x equals 1 minus 1 over x squared. That needs to equal 0. So x needs to equal plus or minus 1. So clearly it has to be, I guess, minus 1, because that would make the sum 0. So x equals minus 1, and we can confirm this with the second derivative, which will be 2 over x cubed. So we want a max, so we need the negative. So you need to choose x equals minus 1 if we want this to be less than 0. Let's check that answer, 317. 1. Oh, find the positive. Oh, minimizes. Yeah, minimizes. Minus 1. I think that's a typo. I think that's a typo because you can see that minus 1 would make it 0, which is obviously smaller than 2, which is what they're saying. Yeah. Find the positive. Oh, Stephen, the positive integer. So you have no choice. Yeah. Yeah, so we have to choose 1 because x has to be more than 0. But let's see. d2y dx squared equals, bring down the power, reduce the power by 1. So we want to minimize it, so it has to be a positive. Yeah, sorry. So x has to equal 1. Yeah, apologies. 318. Find two positive integers so that their sum is 10 and minimize and maximum. Their sum is 10 and minimize and maximize the sum of their squares. Okay. So we know that x plus y equals 10 and z, the sum of their squares, x squared plus y squared. Let's replace the y. So that is x squared plus 10 minus x squared. So that's x squared plus 10 minus 20x plus x squared. So that means z will equal 2x squared minus 20x plus 10. So dz dx for x minus 20 equals 0. x equals 20 over 4, which is 5. And then the problem you can see is you have a choice with y. No, you don't actually. Y has to equal 5. Now, the second derivative, that is equal to 4, which is positive, which means 5 and 5 is a minimum. But for maximum, we need to check. It must be at the boundaries. Must be at the boundaries. So 5, 5 is a min. So therefore it must be 0, 10's a max. If we're allowed 0, that is a max. Or perhaps 1, 9 if we don't include 0. Yeah, I should have also been checking the boundaries. There is no meaningful boundary here, I don't think. And likewise here, I mean, you can't really have x is 0 or x is 1. Here, I also think this might be the boundary because it's the smallest x you can have, the smallest positive integer. So I guess the graph is like this. Yeah. So I just don't know for 3, 1, 8 if we should go with 1, 9 or 0, 10. Positive integer, I would have thought not to include 0. So we'll have to go with 1, 9 and 5, 5. So that minimizes it and that maximizes it. This one here, we said minimizes it. And maximizes it would be infinity. I'll just put that as a note here. X equals infinity will be a maximum. And here, this is our answer. And that would be a maximum. Did I actually check if it was a maximum? Let's see. The second derivative is 24x minus 24. Yeah, that's a positive, which makes it a minimum. No, that's not right then. Yeah, that's not right then. Oh, but I typed the wrong blooming thing in. Yeah, it's a negative then. So that makes it a max then, yeah. And the minimum, by the way, will be at the boundary, which would be like 0, 0, 0, 0, 1. That's the minimum. Well, technically not, sorry. If x is 1, would be 2 by 0 by 1. Those dimensions be a minimum. And then for 315, they only want the largest. The smallest would be 0, by the way. The minimum would be 0 by 0 by 62. So I think that's a good discussion on those 4 questions. Yeah, we'll wrap it up there for today.